Hello everyone, welcome to our channel. In this video, we are going to see Chapter 1 Real Numbers Exercise 1.2 Introduction. In this introduction video, we are going to discuss Theorem 1.2 Fundamental Theorem of Arithmetic. So before going to this theorem, we are going to see what is a prime number and what is a composite number. So a prime number is a number that has only two factors, that is 1 and the number itself. So when we take numbers like 2, 3, 5, 7, 11, if you check with these numbers, you will have factors as 1 and the number itself. If we see 3, we will have factors of 3 as 1 and 3 only, and for 5, 5 and 1, and for 7, 1 and 7, and for 11, 1 and 11. So these numbers are said to be prime numbers because they have only two factors, that is the factor of 2 is 1 and 2, the factor of 3 is 1 and 3, and the factor of 5 is 1 and 5, and the factor of 7 is 1 and 7. So when we come to composite numbers, so what are composite numbers? So what is the difference between the prime number and a composite number is, prime number, as we said, we have only two factors, but in the composite number we will be having more than two factors, and those numbers are called composite numbers. So here if we see a number having more than two factors are called composite numbers. So for example, if we take 4, 6, 9, so if we check with these numbers, we will have the factors of 4 as 1, 2 and 4. And similarly for 6, 1, 2, 3 and 6. So how we get this 2, 4, 2, 3, 6 and all? So we will do by L method. So if we take 6, so we have to divide by 2 first. We have to start with the smallest number, so we have to divide by 2 first. So you will get 2 3s are 6. So next, 3 is a prime number, so it will be divisible only by 1. So we will have 2 and 3 as the factors. So when they ask for factors of 6, we can write 1, 2, 3 and 6. So this is how we find the factors. So similarly for 9. For 9, 3 times and 3 one time. So when they ask for factors of 9, we can write 1, 3 and 9. So when we check with these numbers, that is 4, 6, 9, we can say that these numbers have more than two factors. So those numbers are called composite numbers. 1, 3 and 9. So next what we are going to see is what is HCF and LCM. So HCF is highest common factor. So it can be defined as product of smallest power of each common prime factor. So HCF can be defined as product of smallest power of each common prime factor, and LCM is product of greatest power of each prime factor. So we will see an example for HCF and LCM so that we will get a better understanding of what is HCF and LCM. So we will take two numbers and find LCM and HCF of those two numbers. Let us take an example, 6 and 20. So I am going to find LCM and HCF of 6 and 20. For that, first we have to do by L method. 6. So 2 times. So when we take 6, 2 3s are 6 and 3 one time. And similarly 20. So it will be divisible by 2 since it is a even number. So 2 10 times. Now 2 5 times and 5 1 time. So we can write 6 as 2 into 3 and 20 as 2 to the power 2 into 5. So according to the definition of HCF, now we are going to find HCF. So in HCF, what they have given is product of the smallest power of common prime factor. The product of the smallest power of the common prime factor. So 2 is a prime number and it is the common factor for both 6 and 20. So we have to see, when taking HCF, we have to see the lowest power, product of smallest power of each common prime factor. So in this, the common factor is 2 and we have here 2 to the power 1 and 2 to the power 2. So we will take the HCF as 2 to the power 1 since they have given the definition of HCF as the product of the smallest power of each common prime factor. Common prime factor means we should have a common prime number in both the cases. So we have 3 here and we don't have 3 here, and here for the 20 we have 5 and here we don't have 5. So these both are not the prime factors, so we can skip it. So now we are going to find LCM. So according to the definition of LCM, what they have given, product of greatest power of each prime factor. So when we are going to find LCM, we have to take the greatest power of each prime factor. So here 2 is a prime number, 3 is a prime number and 5 is also a prime number, and they have told highest power, greatest power. So when we take 2, here which is having greatest power is 2 to the power 2. So we have to put 2 square. Next 3. Here we have only 1 3. So into 3 and into 5. So this is the procedure for finding LCM and HCF. So this will be more clear when we start seeing the exercise sums. So what is the HCF is? The HCF of these two numbers is 2 and LCM is 2 square is 4. 4 into 3 is 12. 12 into 5 is 60. So the LCM of these two numbers is 60 and the HCF of these two numbers is 2. So after finding the HCF and LCM, we are going to use a formula to verify that we are getting the correct HCF and LCM. So HCF of A comma B into LCM of A comma B is equal to the product of the two numbers. That is, here the A and B, we take it as 6 and 20 in this example. So what is the HCF of 6 comma 20 is 2 into LCM of 6 comma 20 is 60. So the product of the two numbers, this value should be equal to the product of the two numbers, that is 2 into 60. So we get 120 equal to 120. And this is the introduction video for the fundamental theorem of arithmetic, and the examples will be more clear when we see the exercise sums. The next video we will be starting with the exercise 1.2 solutions. Thank you.